Guys, can we start now? Remember that we were talking about some of the devices that you can use to protect your networks, right? We spoke about firewall. We spoke about the next generation firewall. We spoke about the network control access. And today we are going to start from the Cisco email security appliance. You can also call it, right? Cisco email security appliance, right? So this is a device, right? That device can protect your organization against what? The attack that will come from the emails, right? So this device, basically, you are going to use it to protect your company against email attacks. This is the whole idea of this device, right? You can have your company, you got your computers, you got your switches, your printers, and users, they have to exchange like emails. You need a device that can allow you to protect your emails, the way users are sharing the emails, right? And that device, it's called Cisco email security appliance, right? Now, how this device will work? Like let's say you have a computer here. This is your PC, right? You want to send your email to one of your friends. Your email first will go to what we call what? A firewall. This is the firewall. So the firewall will check if you are allowed to go through the network or not. After the firewall, you are going to have like a router. And that router will have like a switch here. And here they are users, right? So user one, this one, number one, wanna send a message to number two, right? That message will go first to this device, this firewall. This firewall will check if this PC1 is allowed to communicate with PC2. But because we are dealing with emails, there must be another device that will check the email that will come from PC1 to PC2. So you can bring here like another device that we call a Cisco what email appliances, so ESA. So every time a PC1 wanna communicate to PC2 by sending the emails, that email will go to this device, this ESA. That device will check if that email doesn't have some wrong code or malicious code, right? So you got your network one side, like here. This is your company, right? Your company is here. The whole company, like computers, switches, and so on. This guy may be somebody from Durban, maybe your friend wanna send you like an email, right? Your email will come first to this firewall, right? But this firewall will do know what? When your email will come here, your email will be sent first to this device. This device will check if that email doesn't have something wrong, right? If it's okay, this device will send it back and the email will come to you, right? So this is how that device will operate. It's just there to protect your emails, right? So this is the whole design, the way it looks like. Yeah. Now, how this email device will work? This device will work by doing what? By detecting, by collecting like all the data from all over the company, like your company here, right? So that device will collect all your information, your email, the way you are talking, and so on, and update like its database. So that device, this device will have a database. That database will keep all the malicious problems that can happen, right? Now, what are some of the features of this device? This device, number one, can block known threats. What is a threat? A threat is something that can happen, bad things that can happen to your system, right? So this threat is bad event that can happen to your system or apps, right? So that device will allow you to block what? The bad activities. The second one, this device can also detect like bad emails, bad links. Maybe somebody sending you like a wrong link just for hacking you. When that request will go to the SCA, that device will do what? That device will block it. Will block that bad links. So you like here, you are using the computer, but there are so many people who are trying to hack you guys that you cannot see. But there is a specific device that will deal with your emails when you are sending and when you are receiving. So those are the some of the functions of these devices. So for the whole idea about this device, you have only to understand that this device will allow you to protect your company or your organizations against the email attack, right? So when you are using your computer, that device will start monitoring whatever that is coming to you, whatever that goes out, that device will be monitoring the whole company. The second one is what we call Cisco Web Security Appliance. That word web will tell you something, that this device will deal with what? Website. Yeah. So this device will be there to do what? To secure and control what? Your web traffic. So the main ideas of this device is to protect you when you are accessing websites, right? So this device will be sitting somewhere just to check what you guys are doing, right? If there is something wrong that will come from another website, this device will be like in charge of controlling it or stopping it, right? So we spoke about one, for managing and controlling the emails, and for controlling the website, right? So the only things we can just refer to that web. And for web security, you can see that that device can control even your chat, your messaging, your video, whatever that you are doing when you are online. This device will be controlling. It's controlling what? It's controlling if there is no malicious code, right? We spoke last time about the AAA, the AAA components. The first A means what? Authentication. The second one means what? Authorization. The last one is what? Yeah, accounting, right? Please forgive them. Hey, what happened? Yeah. So this AAA component means this. Before somebody or a computer accessing the system, that computer or that user must log in, right? This is the meaning of authentication. So authentication means Nobody must use the system without credentials. This is the first rule. The second A is what? Authorization. What can you do on the system after punching your username and password? What a user can do. We call it authorization. It's like the permissions. The last one is the accounting. Accounting means that nobody must deny what he or she did, like on the system. So when you have your organization, you have to apply those triple A's. So the first one means every user who are accessing the system needs to log in. This is the authentication. Authorization means after logging in, every user must only access what you as an administrator, you assigned to that user, right? And the last one, the accounting means that you must be able to track and audit the activities of all the users. You as an administrator, you must be able to track and to monitor whatever that the guy did, right? Yeah, this is, okay. Now there is what we call 802.1x, right? This one means this protocol or this computer program, this 802.1x means that your computers, so we're not talking about users, we're talking about the devices, right? The devices need to have like sort of credentials. Every device needs to log in before accessing the system. Your switch, right? Suppose like your switch needs to get something from the server. The port from the switch has to have what? Username and password, right? So from this, we're talking about a port, like on the computer side or the device side, right? Like, as we can see, this protocol restricts unauthorized workstation from connecting to the LAN. So this protocol will block some of the computers, will restrict some of the computers to access the system without proper credentials. Because we spoke about the AAA, where a user needs credentials. But this time around, this one will deal with computers. So giving the computers access or not. Right? Now, when you are dealing with that protocol, there is what we call a client or what? A supplicant, right? This is the device that will be running the 802.1x software, right? Like you got your computer, right? Like here, I think I got that one of the picture here. Let me see if I can see it. So I'm just checking that. Yes, we are here. So you can see here, there is this one. This computer wants to access the server. This computer, we're gonna call it what? Supplicant. The switch, we're gonna call it what? How can you read it? Yeah. And the server will be called what? Yeah, so it means this. You as a user, right? You're gonna have your computer. But your computer also needs a permission from the server in order to access the system. Now, when your request will go to the switch, right? The switch will do what? The switch will contact the server, ask the server, this computer, is it allowed to access the system? So the credentials from this computer, they are not here. They are where? Like you're gonna have maybe 100 switches in your company. All those 100 switches, they will have logins, right? Those logins will be saved here. Maybe you have 1,000 computers. All those 1,000 computers, right, will be saved where? Yeah. So for you to access this server, or maybe you want to talk to your friend and so on, the switch first will take your request, send it to the server. This computer, is it allowed or not? Yes, your request will go. No, you're gonna block it. Right? So this is the meaning. But what you must know for the exam, which one is the applicant? There are so many questions they will ask you. Right? They will give you a scenario, they will ask you which one is the authenticator. You must know. So one is asking, one is sending, this one is sending. So this one is this one want to access in the system. You want to talk maybe to your friend who's sitting somewhere else. You want to send him an email, right? Your request will go first to the switch. The switch now is okay. You want to access the other computers. Let me first check if you are allowed. The switch will go to the authenticator server. The server now will do what? We check if that computer is allowed or not. Right? This is the meaning of this protocol. Okay. This is layer 2 security threats, right? How to protect your switches, right? Layer 2, we're talking about switches, right? How to protect the layer 2 devices, how to protect your VLANs and so on. But for this one, I will play a video for you, and you got it already, that video, like on your site too, but we're gonna listen that video like together, and somebody can tell us what he understood from this video. Oh, what happened to voice?
Seen by another virtual local area now.
What's happened now? Oh, I understood what happened because I'm recording, so the voice doesn't want to come from that side. Go to your chapter 10. You go to 5.1. You're gonna find this video, right? So this video talks about how somebody can hack a VLAN, or how somebody can hack VLANs. All right. Just go to 5.1. You put your earphones. It's 5-minute video. When you are done, you come and tell us what you understood about this part, right? Chapter 10, 10.5.1, right? Chapter 10 into 10.5.1. No, yeah, that's one, yeah. 0.5.1. Just listen as way to your own notes.
And this is without the aid of a device such as a router. A VLAN hopping attack is going to enable traffic from one virtual local area network to be seen by another virtual local area network. And this is without the aid of a device such as a router. This is a basic VLAN hopping attack. A threat actor is going to configure a host to act just like a switch. And then using that host, they're going to take advantage of the automatic trunking port feature that's enabled by default on most switch ports. This would be the modes of dynamic auto or dynamic desirable on the switch ports. The threat actor is going to configure the host to spoof those 802.1q signaling and those DTP messages so that the trunk will form between the host and the switch. With a successful trunk established, they're going to be able to send and receive traffic on any virtual local area network, effectively hopping between any VLANs that they want to connect through. With a VLAN double tagging attack, a threat actor is going to embed a hidden 802.1q VLAN tag inside of a frame that already has an 802.1q VLAN tag. What's going to happen here is we're going to have an attacker that's going to double tag a frame. For example, our attacker was going to build a message that's going to communicate from its current VLAN, which is VLAN 10, with a targeted VLAN of VLAN 20. With the attacker currently being on VLAN 10, they're going to build a frame that's going to have an external VLAN header on it of VLAN 10, and then an internal tagged VLAN of VLAN 20. When that message is sent up to the first switch, our first switch is going to see the external outside header of VLAN 10. It's going to strip that off and then send this traffic on its way to any device running in VLAN 10. Well, the switch sees that VLAN 10 is also the native VLAN, so it's going to remove the VLAN 10 header and move it across the trunk link. Now, as that frame moves across the trunk link, the first header of VLAN 10 was removed. And now the internal tag, which is the VLAN 20, that still exists. This second switch is going to receive that frame. It's going to strip off that VLAN 20 header, and then it's going to forward it out any VLAN 20 ports, which includes down to that targeted host. This is effectively allowing our threat actor machine on VLAN 10 to communicate to the target on VLAN 20 using a double tag. Now, VLAN hopping and this whole idea of VLAN double tagging, they can both be prevented by putting in a couple security guidelines. Number one, we should get rid of trunking on any access port that goes to end devices. Also, the whole idea of auto trunking, using things like dynamic desirable and dynamic auto, that should be disabled. We should use a manual static trunking as needed. Also, native VLAN should only be used on trunk links, and that native VLAN should never span to a user device. For instance, in this scenario only works when the threat actor is on the same VLAN as the native VLAN between our switches. DHCP is a powerful tool for easy dynamic addressing across our networks, but it can also be a powerful tool for malicious threat actors that want to have some fun with a network. So, quick recap of DHCP. We have DHCP servers that are going to dynamically provide addressing for us. That addressing includes IP addresses, subnet masks, default gateway, DNS servers, and even more with DHCP options to our clients. The typical conversation with DHCP goes back to DORA. Discover, offer, request, acknowledge. Our client's going to send a broadcast message, which is a discover. A server is going to hear that broadcast message and respond with a unicast offer of, this is what I can give you. Here's some addressing info. The client receives that offer, it's very excited, and it sends out a broadcast of, I accept the offer you sent me. That server finishes it up with a unicast saying, you like the offer, I'm glad, I acknowledge. And then the lease is complete regarding the client taking that addressing info. It sounds easy enough, but now let's bring in an attack. Now it sounds funny saying it, but there's two common types of DHCP attacks. We've got the DHCP starvation attack and DHCP spoofing. With DHCP starvation, the goal of the threat actor is to create a denial of service for your connecting clients. What would happen is the threat actor would gobble up all of the usable DHCP provided addresses. The easiest way to go about this is having a threat actor using a client machine that's cycling through source MAC addresses very quickly, and for each source MAC address, gobbling up an available IP address being given by your DHCP server. When all the addresses are taken from the DHCP server, there's nothing to provide the legitimate clients. On top of that, there's the DHCP spoofing attack. Imagine having a threat actor putting out their own DHCP server on your network. And when your clients use the whole DORA process and they broadcast out for a discover, and then there's the offer, the request, but then your rogue DHCP server finishes the conversation with the client with an acknowledgement providing wrong default gateway info, incorrect DNS servers, as well as even wrong IP addresses for the clients to use. Effectively, your legitimate clients cannot communicate on the network. So we have to prevent this by using safeguards and implementations for security. Address resolution protocol is a powerful protocol on our networks that allow our networks to function. With ARP, we're talking about having a known IP address being mapped to an unknown MAC address. And this is being used all the time with our devices on the network. Now, a client can send an unsolicited ARP reply, which is known as a gratuitous ARP. It's really a broadcast that we have a specific IP address that is mapped to a specific MAC address. Now, the problem is when someone sends out a gratuitous ARP as a broadcast, other devices, which should be hosts as well as network switches, are going to store that MAC address and IP address combo in their ARP tables and MAC address tables. This is an issue because a threat actor can send a gratuitous ARP message with spoofed information inside of it. This effectively allows any host to claim to be the owner of any IP address and MAC address combo that they want to. So let's talk about it. Here in our graphic, we've got PC1, PC2, and R1. They all have ARP caches that are up to date and correct. But what's going to happen here is PC2, the threat actor, is going to send out a gratuitous ARP. And that gratuitous ARP is going to claim that 10.0.0.1, the IP address of the router, is reachable by using MAC address all Cs, which is the MAC address of the threat actor. Also, the threat actor PC2 sends out a gratuitous ARP claiming that 10.0.0.11, which is the IP address of PC1, is reachable with MAC address all Cs, which is again the attacker. So what's going to happen here is when PC1 sends data to the 10.0.0.1 IP address, it'll be sending it at layer 2 to the attacker, which is all Cs. When the attacker receives this data, it'll be using it as a man-in-the-middle attack. When the router responds to 10.0.0.11, the router will be responding to the layer 2 target, the MAC address of all Cs, which again is going to be the threat actor. So what it comes down to is exactly this. PC1 will want to send data to 10.0.0.1, and to do so, it'll send it to the MAC address of all Cs, which is PC2. PC2 forwards that data onto the router. The router will send it outbound to where it needs to go. As the router responds back to the 10.0.0.11 IP address, it'll be responding back, targeting all Cs, again the MAC address of the threat actor. This is a beautiful man-in-the-middle attack. Spanning tree is a protocol that is on by default on our Cisco switches. Its job is to provide us redundant connections while maintaining loop-free pathways, and it does it great. But the problem is threat actors can utilize spanning tree to actually change the topology of your network infrastructure. Now, the way they would do this is based off of logical, not based off of physical connections, but they would make their host appear as a root bridge. To do this, they would be sending out bridge protocol data units, which are spanning tree layer 2 messages. And these messages will include a priority of something insanely low, such as 0, for example, here in our graphic. By sending out these spanning tree messages saying that their priority is insanely good, the network infrastructure will view that threat actor's host, which is pretending to be a switch, as the root bridge. And they will all find the best way to reach the root bridge, which means they'll be dropping their main connection between each other and connecting through that switch itself. This allows the threat actor machine to pretty much act as a man-in-the-middle style attack and to be able to see all network traffic moving across this network domain. Cisco Discovery Protocol is a Cisco proprietary Layer 2 link discovery protocol. This thing is amazing. It can be used to verify Layer 1 and Layer 2 connectivity. And the cool thing is it's on by default on all Cisco devices. Now, on that same point, it can be insanely scary that it's on by default on all devices because this is used to automatically discover other CDP-enabled devices that are directly connected. This can even be used to auto-configure some of their connections. Now, while CDP is extremely useful in network troubleshooting, our threat actors can use it to easily discover network infrastructure vulnerabilities. For example, the CDP information that's being sent out, it's being sent out periodically and as unencrypted broadcasts. This information that is periodically sent out and sent out in an unencrypted format includes the IP address of the Cisco device. It includes the Cisco Internet Networking Operating System version. It includes the platform and even based off of the capabilities of that model of the device. It even includes VLAN information and more. So here's a graphic pulled off of a protocol analyzer showing a CDP message and ripping it apart in this unencrypted, unsafe protocol reaching out to our end devices. So how can we stop our end devices from receiving this periodic unencrypted CDP laden full of info of greatness? Well, 2 commands. We have no CDP run. No CDP run is put in the global config mode of your device, and that will turn off CDP everywhere on your Cisco device. Or you want to leave CDP on for those inter-network device connections between Cisco devices, but just off on the user interfaces. That would be the command no CDP enable. That's in interface config mode, and that's what you use on your interfaces connected down to end devices. We also have LLDP, which is Link Layer Discovery Protocol. It's a ventral neutral flavor of CDP. This is also vulnerable to recon attacks. We can turn this off globally in our global configuration mode using the no LLDP run command, as well as if you want to do interface specific commands, we can use no LLDP transmit and also no LLDP receive, respectively.